ground beneath Santorini is trembling again, not with a single violent jolt, but with thousands of whispers. More than 25,000 earthquakes have pulsed beneath this island, and scientists are asking a question no one on the surface can hear.
Yeah, it's absolutely
What is rising from below? The Aegean Sea glows under the Mediterranean sun.
Noted.
Its
Checking the
waters
logs
calm,
now.
Good. Cross-check
almost
with the other
glass-like.
On it.
Whitewashed houses cling to black volcanic cliffs. Blue domes shimmer against the sky. Tourists laugh along narrow stone paths. Cameras click. Wine glasses clink. Everything feels timeless, eternal, untouchable. But deep beneath this postcard paradise, something is shifting. The wind drifts softly across the caldera. Boats float peacefully in its flooded crater. From above, the island looks serene, like a sleeping giant bathed in light. Yet below the boats, below the cliffs, below layers of hardened lava and ash, pressure is building in silence. At first, no one noticed. The earliest tremors were too small to feel, too subtle for human senses. Only machines heard them. Seismographs placed quietly around the island began tracing thin, nervous lines. Each line a vibration, each vibration a fracture in the crust. Then the lines multiplied. Dozens, hundreds, thousands. Scientists watching the monitors leaned closer. Patterns began to form. Not random, not ordinary tectonic noise. These quakes were clustered, concentrated, rising from beneath the caldera itself. The numbers climbed. 5,000, 10,000, 20,000. Now more than 25,000 seismic pulses have been recorded beneath Santorini in a relatively short geological window. Each one small, each one brief, but together they form a message. Something underground is moving. Silence hangs in the monitoring rooms where geophysicists watch their screens. Fluorescent lights hum overhead. Coffee grows cold beside keyboards. Eyes scan waveforms that ripple like heartbeats, because they know what this pattern can mean.
Sector 7. Check the waveform.
Magma.
Confirmed. It's climbing fast.
Far below the
Reroute
island
power, monitor
lies
cascade.
On
a
it,
vast
watching.
volcanic system carved by ancient eruptions. Santorini is not just an island. It is the exposed rim of a colossal caldera. A collapsed volcanic crater formed when the Earth itself gave way after a catastrophic explosion thousands of years ago. Beneath that crater sits a complex network of molten rock reservoirs, magma chambers, conduits, fractures, pathways carved through stone like veins beneath skin. Most of the time, this underground world sleeps, but not always. When magma begins to rise, it forces its way upward through cracks in the crust. Rock resists. Pressure builds. And the Earth responds with earthquakes.
These projections show a significant
Small
shift.
ruptures
Agreed,
signaling
but the
that
eastern
something
region is stable.
below
The
is
timeline
pushing.
concerning.
Let's review the
That
assumptions.
is what the instruments are detecting now. Not a single surge, not a sudden blast, but a slow, persistent ascent, like breath returning to a sleeping giant. In laboratories across Europe, researchers compare seismic data with satellite measurements.
This view is
From
breathtaking,
orbit,
isn't it?
satellites
Absolutely,
can
it's
detect
magical.
movements
We should get
of
a
the
photo here.
ground
Good idea.
smaller than the width of a coin. They scan Santorini's surface again and again, mapping elevation changes invisible to the human eye. The results are unsettling. Parts of the caldera floor appear to be swelling. Not dramatically, not explosively, but
The
measurably.
readings are spiking. We need to
The Earth
stabilize
is
it.
lifting,
Containment fields are at
millimeter
60%.
by
Diverting auxiliary
millimeter.
power now.
It's
That
stabilizing.
subtle rise suggests pressure is accumulating underground, magma entering a chamber, gas expanding, rock bending. The crust behaving not like solid stone, but like a slowly inflating membrane. Inside monitoring stations, the tension is palpable. No alarms blare, no sirens sound. But scientists know this pattern. They have seen it before.
The data here supports our
At
expansion.
volcanoes around
Yes,
the
but what about
world
the
that
risks?
later
The
erupted.
projections look positive.
The signals
review the
do not
costs.
guarantee an eruption, but they never appear without a cause. Time seems to slow on the island. Waves lap gently against black volcanic rock. church bells echo faintly through white villages. Evening light paints the cliffs gold. Life continues as if nothing has changed. Yet underground, the pressure continues to climb. Invisible gases
Spike in
seep
Sector
through
7. Check the
microscopic
waveform.
cracks in the
Confirmed.
earth.
It's climbing fast.
For
Reroute
carbon
power, monitor for
dioxide,
cascade. On it,
sulfur
watching.
dioxide, steam. Instruments placed near fumaroles measure subtle fluctuations in chemical composition. Even tiny shifts in volcanic gas ratios can reveal what magma is doing kilometers below. Some readings suggest fresh magma may be entering the system. Fresh magma means heat. Heat means expansion. Expansion means stress. And stress, eventually, seeks release. Scientists do not panic. They calculate. They compare historical records. They run simulations. They examine rock samples and seismic wave velocities. They debate interpretations in quiet conference rooms filled with maps and graphs. But beneath their calm voices lies a shared understanding. Santorini has done this before. More than 3,600 years ago, this same volcanic system unleashed one of the most powerful eruptions in human history. The explosion was so immense it blasted ash high into the stratosphere. Pyroclastic flows surged across the sea. The island's center collapsed inward, forming the caldera that exists today. The eruption reshaped coastlines across the Aegean. Tsunamis slammed into distant shores. Entire settlements vanished beneath ash. The sky darkened, crops failed, civilizations faltered. That ancient event did not just change Santorini, it altered history. Geological layers preserve its memory. Thick bands of pale ash buried deep in the earth like frozen smoke from a catastrophe long past. Scientists can trace those layers across islands and continents, a signature of unimaginable force. And now, the same volcanic system is stirring again. Night falls over
The readings are
Santorini.
spiking. We need to
The
stabilize.
villages
Containment
glow
fields are at
softly with
60%.
lantern
Diverting
light.
auxiliary power now.
Restaurants
It's
fill with
stabilizing.
conversation. Music drifts through narrow alleys. Above, stars scatter across the sky. Below, tremors continue. Most are too faint to feel. A glass of water would not ripple. A hanging lamp would not sway. But instruments record each vibration with relentless precision. Another fracture, another shift, another sign of
The data here
movement
supports
beneath
our
the
expansion.
crust.
Yes, but what about the
Clusters of
risks?
quakes
The
appear at
projections look
similar
positive.
depths.
Let's review the costs. Agreed.
That clustering suggests a migrating source. Magma forcing its way through rock layers, cracking stone as it advances. The pattern resembles footsteps, slow, heavy, approaching. Scientists analyze the depth distribution.
These
Some tremors
projections show a
originate several
significant shift.
kilometers
Agreed, but
below the
eastern region is
caldera.
stable. The timeline is
Others
concerned.
appear
Let's
slightly
review the
higher.
assumptions.
This vertical migration is critical. It may indicate magma ascending through the crust towards shallower
spike. It's
reservoirs.
anomalous.
If it
Noted.
continues
Checking the logs now.
rising,
Good. Cross-check with the other
the
metrics.
the
On it.
system could destabilize. A volcanic eruption does not begin at the surface. It begins with pressure underground reaching a breaking point. Gas trapped within magma expands as it rises. The expanding gas shatters rock, opening pathways upward. If the
These
pressure
projections show a
exceeds the
significant
strength
shift.
of the
Agreed, but the eastern
overlying
region is
crust,
stable. The timeline
the
is
result can
Let's
be
review the
explosive. But eruptions are not all the same. Some release lava slowly, like a wound bleeding molten stone. Others detonate with catastrophic violence, pulverizing rock into ash and blasting it skyward. Which path Santorini might take depends on chemistry, gas content, and pressure conditions deep below. Variables scientists are racing to understand. Computer models simulate thousands of scenarios. Screens glow with digital renderings of magma chambers and stress fields. Researchers adjust parameters, watching how virtual Santorini behaves under different conditions. Most simulations show no immediate eruption, but some scenarios reveal the possibility of escalation if magma supply continues. That uncertainty is what keeps scientists watching. because volcanoes rarely announce their intentions clearly. They speak in fragments, in signals, in patterns that must be
The readings are
interpreted like
spiking.
a
We need to
coded
stabilize it.
language written in
Containment fields are at
stone.
60%.
Diverting
Dawn
auxiliary power
breaks
now.
again
It's
over the
stabilizing.
caldera. Sunlight spills across the cliffs. Seabirds wheel overhead. Ferries cut gentle wakes through the water. To visitors, the island feels peaceful, safe, eternal. They do not see the data. They do not hear the underground fractures. They do not feel the pressure building kilometers below their feet. In research centers, teams exchange updates, seismic counts, ground deformation maps, gas emission charts. Each data set is another piece of a puzzle still forming. No single signal confirms danger, but together they form a picture scientists cannot ignore. Santorini is not erupting, not now, but it is restless. The earth beneath the caldera is behaving like a system awakening from dormancy. Not violently, not suddenly, but unmistakably. A low-frequency tremor hums through sensitive instruments. A different kind of seismic signal. Unlike sharp quakes, these vibrations resemble a continuous murmur. Volcanologists sometimes call it harmonic tremor. It can occur when magma or volcanic fluids move through underground conduits. A subterranean resonance, a sound no human ear can hear, yet its presence can mean the volcano's internal plumbing is active. The possibility hangs in the air like humidity before a storm. What would happen if Santorini did erupt? The scenario would not unfold in an instant. There would likely be escalating warnings,
Wow, this view is
stronger quakes,
breathtaking.
faster ground
Yeah, it's
swelling,
absolutely stunning.
increasing
We should take a
gas
picture.
emissions. Authorities
this
would
spike. It's
analyze
anomalous.
every signal,
Noted. Checking the logs now.
weighing
Good. Cross-check with the other
evacuation
metrics. On it.
decisions against uncertainty. If magma reached the surface, the first visible sign might be steam explosions where seawater contacts hot rock, plumes of white vapor rising from the caldera, then ash, dark columns punching into the sky. Aircraft rerouted, shipping lanes closed. Ash clouds could drift across the Mediterranean, carried by high-altitude winds. Fine volcanic particles can damage jet engines, disrupt electronics, and reduce visibility. Aviation authority ties across Europe would monitor every plume trajectory. Closer to the island, falling ash could blanket rooftops and roads. Not glowing lava, but powder. Silent, relentless, each grain a fragment of shattered earth. In more intense scenarios, explosive activity could send pyroclastic surges racing across the caldera surface. Fast-moving avalanches of gas, ash and rock hotter than a furnace. Such events are rare, but Santorini's geological history proves they are possible. Even a moderate eruption would reshape the landscape. New lava domes might rise from the sea, coastlines could shift. The island's outline itself might change, as it has many times before. Yet the greatest impact might not be local. Volcanic eruptions can influence climate. Large explosions inject sulfur aerosols into the upper atmosphere, reflecting sunlight and cooling the planet temporarily. The effect depends on eruption size and altitude of the plume. Scientists cannot predict whether Santorini could produce such an event, but they know it has, and once. That ancient eruption did not just alter geography,
Spike in Sector
it
7.
left
Check the
traces in
Confirmed,
ice
it's climbing
cores
fast.
thousands of
Reroute power.
kilometers
Monitor for
away.
cascade.
On it, watching.
Chemical fingerprints preserved in polar ice testify to the scale of what happened here long ago. The past is not dead beneath Santorini. It is buried, waiting. Evening returns, lights flicker on along the cliffs, conversations rise from terraces overlooking the caldera. Laughter echoes, glasses clink. The sea reflects the glow of the villages like liquid fire. Beneath that beauty, the earth shifts again. Another tremor, another fracture, another whisper from the deep. Inside monitoring stations, seismograph needles twitch. Scientists log the time, magnitude, and depth. The count increases. 25,000 quakes and rising.
These projections
Each
show
one
a
alone
significant
means
shift.
little.
Agreed, but the eastern region is
Together
stable.
they tell a
The timeline is
story
concerning.
still
Let's review the
unfolding.
assumptions.
The island does not shake violently. No cracks split the streets. No smoke rises from the crater. To the human eye, nothing appears wrong. But instruments do not rely on sight. They listen. And what they hear beneath Santorini is movement. Slow, persistent.
This view is breathtaking,
patient.
isn't it?
Absolutely.
Like
it's
something
magical.
gathering
We
strength
should
in
get
the
a photo
dark.
here.
Good idea.
Volcanoes operate on timescales beyond human intuition. Days mean nothing to them. Years are moments. Pressure can build for centuries before release, or it can fade quietly, the magma cooling and solidifying without eruption. That
readings are
uncertainty
spiking.
is
We
the
need to
nature
stabilize it.
of
Containment
volcanic
fields are at
systems.
60%.
Diverting
It is
auxiliary power
also
now.
what makes
Stabilizing.
them so dangerous, because the difference between silence and catastrophe can lie hidden kilometers underground. The wind rises over the caldera, carrying the scent of salt and stone. Waves strike the cliffs with hollow echoes. Fair below, unseen forces continue their work, reshaping rock,
The data here
shifting
supports our
pressure,
expansion.
rearranging
Yes, but what about the
pathways
risks?
in
The
the
projections
Earth's
look positive.
crust.
Let's review the costs.
No one
Agreed.
knows exactly what will happen next. Not the tourists watching the sunset. Not the villagers pouring wine. Not even the scientists studying every tremor. They can measure the signals. They can model the physics. They can interpret the data, but they cannot command the volcano. Santorini remains breathtaking, timeless, serene, and
Spike in Sector
restless.
7. Check the waveform.
Because somewhere
Confirmed, it's
beneath
climbing
its
fast.
tranquil
Reroute
waters
power,
and
monitor for
sunlit
cascade.
cliffs,
On it, watching.
magma may still be rising. Inch by inch, fracture by fracture, writing the next chapter of a story that began thousands of years ago and has never truly ended. The island waits. The instruments listen, and deep below the caldera, something is still moving.